Good morning, everyone. Welcome back for the day 4 of FDP on Sustainable Development in Civil Engineering, organized by Department of Civil Engineering, Mysuru. Thank you all for joining us today. Joining us for today's webinar. Myself, Kanmani S, serving as Assistant Professor in the Department of Civil Engineering, VIDYAVARDHAKA College of Engineering, Mysuru. I'll be the MC for today's webinar on Understanding Sustainability, Adopt, Assess, and Mitigate by Dr. AJIT SABNIS, Principal Consultant, ASP SDI, Sustainability Assessment Consultancy Firm, Bengaluru. Now, to begin with, I request our Professor, Sharmila A, to welcome the participants and the speaker.
Dear faculty members, research scholars, practicing engineers, students, very good morning to one and all. It's given me immense pleasure to speak about our institution, VIDYAVARDHAKA College of Engineering and Department of Civil Engineering, and also to welcome everyone to 4th day of FDP on Sustainable Developments in Civil Engineering for the session on Understanding Sustainability, Adopt, Assess, Mitigate, being presented by Dr. AJIT SABNIS, Principal Consultant, ASP SDI, Sustainability Assessment Consultancy from Bangalore. I'm extremely happy to speak about our institution, VIDYAVARDHAKA College of Engineering, popularly known as VVCE, which is situated in the heart of city of Mysore. It is one of the most prestigious and popular engineering college in the state of Karnataka. VVCE has been accredited by NBA and NAAC with A grade. It has been granted autonomy from VTU, Belagavi, from the current academic year. It has 6 UG and PG programs. A new UG program on artificial intelligence and machine learning will be starting from this academic year. The Department of Civil Engineering has 60 intake. It is recognized research center of VTU. It has very young, dynamic, and dedicated faculty members from all specialization of civil engineering with an average age of about 36 years. It has excellent laboratory infrastructure, very good teaching learning ambience with a focus on practical training, very good faculty-student ratio, concentrating on society-driven research and many other facilities. On behalf of our department, I wish to welcome today's speaker, Dr. AJIT SABNIS, Principal Consultant, ASP SDI, Sustainability Assessment Consultancy from Bangalore. Sir will be delivering a lecture on Understanding Sustainability, Adopt, Assess, Mitigate. I welcome you, sir. I welcome all the participants to today's session. I welcome Dr. Dayananda HS, Dean Academics, Dr. S.K. Prasad, HOD, Department of Civil Engineering, and all my colleagues of VVCE, both from teaching and non-teaching community. I welcome one and all. Over to Kanmani, madam.
Thank you, madam. Now I request Professor Abhilash BL to introduce the speaker.
Good morning, one and all. It's my privilege to welcome today's speaker, Dr. AJIT SABNIS. He is Principal Consultant, ASP SDI, Sustainability Assessment Consultancy Firm, Bengaluru. Dr. AJIT SABNIS, sir, is graduated from BMS College of Engineering and post-graduated from Indian Institute of Technology, Madras, and doctorate from Jain University, Bengaluru. He has total experience of 40 years in the field of construction sectors. He has, to his credit, more than 350 completed projects in India and abroad. During the tsunami days, that is 2004, he offered his service as a consultant to Red Cross at Maldives. A member of TC40, a committee under Asian Council of Civil Engineers, he is also the project director of 3 sustainable projects under United Nations Environmental Program, that is UNEP, India. His specialization provides sustainability assessment of buildings and infrastructures projects prior to actual construction phases, enabling concerned stakeholders to evolve and adopt right kind of methodology, technology, and global warming mitigation and ozone depletion potential strategies moving towards the sustainable development. His passion to disseminate the right kind of field of knowledge among the civil engineers fraternity made him to initiate the publishing and reference magazine called Built Expression in Bangalore, which won the Best Indian Construction Industry magazine title in 2012. He has published several articles and technical papers in various magazines and international journals. Once again, we welcome you, sir. Over to you.
Thank you, Abhilash. Good morning, participants.
Sorry to disturb you, sir.
Yeah.
Just a little housekeeping before we get started.
All right. Yeah.
Okay. Dear participants, if you have any questions during the presentation, please type them into the chat box. We will bring them up at the end of the session. Every day, e-certificate will be provided to those who participate in the webinar and submitting the feedback. And 1 week FDP e-certificate will be provided to all the faculty members who register and actively participate in the FDP and submit the feedback. Further instructions regarding the sessions will be shared in the Telegram group and to the registered mail IDs. The link for feedback will be posted in the chat box of YouTube at the end of the webinar. And the feedback link will be open or will be active till 5 o'clock. Now, without a further ado, we'll turn over the time towards Dr. AJIT SABNIS, our presenter today. Over to you, sir.
Yeah, thanks, Kanmani. Thank you very much. Good morning, participants. I hope I'm audible.
Yes, sir.
Yeah.
Yes.
Okay. Yeah. Good morning, participants, and good morning, one and all. Before I actually begin, let me thank VIDYAVARDHAKA College of Engineering and its faculty, and especially my good friend, Professor Dr. S.K. Prasad, and my young friend Abhilash, and host of others for giving me this opportunity to share some of my views on the current topic, which is actually the need of the hour. Understanding sustainability, adopt, assess, and mitigate. You will understand why adopt and the necessity of assessment, and then how do we provide mitigation strategies to the existing current problem. The whole thing we will see as a part of it. One of the biggest challenges of 21st century is going to be the challenge of climate change. How do we actually approach this problem? How do we actually solve and address this issue of climate change? What is the impact of climate change on the day-to-day life? What is the impact of climate change on our other species, not only on human species, but how does it affect on the other species living on the planet Earth itself? Why it is so important, and then what civil engineers, as engineers, what is our role? What exactly are the sustainability development goals? What are they? All these things, we will briefly look into it in the next 45 to 60 minutes. But before I go into the details, it is absolutely necessary for us to understand some of the fundamental terminologies, what we use in sustainable engineering. I'm sure most of you are aware of quite a few things, but let us recapitulate those things in a more technical way, and then let us first, it's basically half of the problem is done once we understand the terminologies involved in it. The environment itself can be actually differentiated between natural environment and then built environment. Now, we are more concerned with the built environment. Natural environment is all that what we see, the rivers, the air around us, everything that is around us, which is natural. That is natural environment. Now, the built environment, how do we define built environment? Now, the term which is on the screen, the term built environment refers to the human-made surroundings that provide the setting of the human activity, ranging in scale from buildings to parks to infrastructure projects. It has been defined as the human-made space in which people live, work, commute, and recreate on a day-to-day basis. In a nutshell, all that we build, we human beings build for our own comfort, for our own living, etc., is called the built environment. It will be roads, it is the houses, it is the power station, it is everything, whatever we build, whatever we demolish, everything we do for human comforts and then human greed, that all comes under the built environment. Now, after built environment, what exactly is sustainability? How do we define sustainability? We have many definitions for sustainability. The National Building Code 2016 Part 11, which is Approach to Sustainability, a new introduction into the National Building Code part of it, and these actually defines sustainability as the state in which components of ecosystem and their functions are maintained for the present and future generations. See, the present and future generations is to be underlined here. Sustainability never means that it should be our needs, the present needs, and then the present requirements, present growth, present industrialization should be completely negated, and then everything should be stored or reserved for the future generations. That is not the definition of sustainability. Sustainability, we will, as we go further, we will understand the true meaning of sustainability, but it is, we have to look after the present generation needs also, and the future generation needs. So that is the definition of sustainability as per NBC. Now, the World Commission defines sustainability as in terms of sustainable development. So sustainable development is that which meets the needs of the current generations without compromising the ability of future generations to meet their own needs. Yeah, both are intent, in spirit, both the definitions are same. I had an opportunity to spend some one-to-one time with a former president, Dr. APJ, and I asked him, sir, how do you define sustainability? So he told me only one thing, all the definitions of the present science, etc., etc. Gandhiji had told the definition of sustainability in a very, very simple single sentence. He said, the line drawn between the need and the greed is what is sustainability. Such a beautiful, profound statement done earlier, available to us right from the beginning. Sustainability is also actually encompasses the three important aspects: reduce, reuse, and recycle. Now, what do we reduce? What do we reuse? And what do we recycle? This is actually the role where engineers play a major role, a critical role, and then that is how we let us go about it. So I'm sure all of us have heard what is 3R, and the same principle of 3R, reduce, reuse, and recycle, forms the fundamental tenet of sustainability. Now, what exactly is sustainable development and what exactly is sustainable construction? We will just look into it briefly, and then we will go into the terminologies further. Now, the next slide. Now, buildings not only are constructed with inert materials, that is what the general opinion is, but no, buildings are, to me, actually, they are living beings. Why are they living beings? The buildings respond to the environment which is next to it. If there is an environment is adverse, if the environment is bad, then the buildings react accordingly. If there is a foul smell outside in the environment, in the building there becomes the foul smell. So whatever the environment is, the buildings reflect and then react to that and respond to that environment. For example, if we have a corrosive atmosphere outside, the buildings start responding to it in terms of corrosion. So these are the important things. That is why buildings interact with the environment in various ways throughout its entire life cycle, from pre-construction to demolition stage. Now, all the four cycles are absolutely important. The life cycle of a building, if you take the pre-construction phase, the construction phase, the operating and maintenance phase, and lastly is the demolition phase. So this is the life cycle of a building, and this also is the life cycle of a product. If you take a particular product, then what is it in the initial stages and what is it in the present stage and how, during its maintenance and operation stage, and then the entire thing becomes a life cycle from its inception to the demolition part of it. Now, we endeavor to minimize a building's resource consumption, waste generation, and overall ecological impact to within certain nationally accepted limits. So this becomes extremely important. So in sustainability or sustainable development, we have to use. It is not that we should not use sustainability or the advanced technologies or technological advancements should not be considered. This is a myth. And please understand that sustainable development is not going back to the olden days, etc., etc. But in the present system, under the present circumstances, we need to evolve. We need to base our further development based on the wisdom what we have acquired from the past. So that is more important. Now, sustainability is extremely complex phenomena. Now, and so are the pathways, and so are the solutions. So if you see in the screen, for example, these are called actually the built environment interactions. There are what are called as a lot of indicators, etc., etc. United Nations framework actually identifies more than 500 sustainability indicators that are to be accounted for the appropriate assessment of sustainability. What you see on the screen is actually only 75 such indicators, and then the parameters, and then there are the connected and interconnected. Now you can actually understand how complicated the entire assessment of sustainability is. So to be very frank, it is impossible for anyone to assess the sustainability to its maximum limit or to its entire in its entirety. We can only take the maximum, the most impactful parameters, and then look at them. Now, there is a construction sector is absolutely important. The construction sector's contribution to the adverse environment is also very, very critical. And then let us just see what exactly is that. Now, let us look at the contribution of the construction sector. Globally, buildings are all responsible for about 40% of the energy that is produced in the globe. The entire energy produced in the globe construction sector consumes about 40% of it. An estimated 42% of the global water consumption and 50% of the global raw materials are consumed by construction industry. And thirdly, estimated 50% of the world's air pollution, 42% of its greenhouse gases, 50% of all water pollution, 48% of solid waste, and 50% of chlorofluorocarbons are all due to built environment, that is directly or indirectly because of the construction industry. So dear friends, what this reflects is construction industry directly or indirectly is responsible for approximately 40 to 50% of the impact that is happening in terms of sustainability or in terms of adverse effect on environment. So what is the basic genesis of the entire thing? Genesis of the entire thing is the built environment. So that is, and built environment comprises, as I said, infrastructures, buildings, everything that we build for the human comfort. And then this is where the engineers, architects, designers, etc., etc., and all those people who are directly or indirectly connected with the construction industry come into the picture. And we have to owe that responsibility. Now, if we have the global picture in this phenomena, now let us just look at what exactly is the carbon footprint as far as India is concerned. Now, India stands, sometimes they say third, sometimes it is fourth, but anyway, now it is almost on the third position in terms of greenhouse gas emissions or into the natural environment at international level. Now, first USA, second is China, and third actually was all the Europe unions together, and together they actually emit about 55 to 60% of the total greenhouse gases into the atmosphere. India, though it is in 4th position, it emits about 7 to 8% of carbon dioxide into the atmosphere. This emission of carbon dioxide or greenhouse gases is considerably reduced in the last 3 to 4 months because of the corona effect, and then because of the lack of activities that are happening, etc., etc. But please mind it that just because the air pollution has reduced, the effect of global warming has not been reduced. It still continues to look into our eyes. I will tell you in the future slides why that is slow, or why that is so. Now, India emits about 7 to 8% of total greenhouse gas emission, and in that 7%, approximately 40 to 50% is contributed by the construction industry, and this 40% of the emission, it can be divided actually into energy produced and consumed or the greenhouse gases emitted to the ratio of 75 to 80% or to 20 to 25%. Now, this pre-operating and maintenance phase, what you are seeing at a 70 to 80%, is more or less streamlined. This part of the life cycle of a building comes after the construction is over. Now, once the construction is over, during the operation and maintenance field, it is the energy consumption, everything is almost uniform, especially with the advanced technology and the streamlined gadgets, all those things, more or less the energy consumption is streamlined across the globe. But what is neglected is this pre-construction and construction phases, which actually contribute to about 20 to 25% of the total emission into, and this Indian scenario approximately works to the same percentage at the global level, etc. Now, we have seen huge amount of unprecedented events in the recent times. What actually are we seeing? The global warming or the warming of the earth and the consequent climate change is happening, whether we understand it or we don't understand it. Increased carbon dioxide concentration in the atmosphere has been going on. The rapidity with which greenhouse gas emission is increasing, the rapidity with which ocean acidification is happening. The ocean acidification is happening in a rate which has never happened in the last 300 million years. The ocean waters are warming up at even 700 meters deep in the ocean. Rapidly changing rainfall patterns, accumulating waste, urbanization and rural migration. We were all listening to it and when we were all hearing about it, but nowadays I think all of us had an opportunity to understand what exactly is rural migration, what exactly is reverse migration, what exactly is urbanization. So this, in the last 4 or 5 months, because of the corona effect, because of the COVID effect, all those people who came looking for the jobs, looking for better lifestyle, etc., from rural areas, they came to urban areas. And then now that is the migration. That is called the urbanization. They come here, they settle, they start working, and then when that urbanization, migrated population increases, then the whole cycle, the requirement of infrastructure, etc., grows continuously. Now, what we have seen in the last few days is the reverse migration. The reverse migration means from people are not happy, people are afraid, people are they would like to go back to their villages from the safety point of view. So this is a reverse migration which was never anticipated so early. So these are such unprecedented events what we are seeing. Now, melting of glaciers, the floods what we have seen, and lot of anthropogenic calamities also we have seen. Anthropogenic is human related activities or human caused activities. Now, another important phenomena that we are observing is polar amplification and then permafrost. You can actually go and refer these two terminologies, make your own search and then study. The polar amplification actually is the melting of ice at the polar level, so exposing the black rock and then exposing the rock condition. So when the rock is exposed, the more the heat comes into the picture, more the heat, more the melting. So glaciers will melt, and then as the glaciers melt, they all add to the ocean waters, the increase in the level of the ocean water. And then these are the effects, so the rise in the level. And also, the more the heat gets reflected back into the atmosphere, the higher the warming up of the earth takes place. Right? Now, let us look at what exactly is the urbanization cycle. Now, we talked about urbanization. I gave you the example of now how rural people come into the picture. So that causes urbanization. They come in search of good job, better living style, better education for their children, etc., etc. And then that is urbanization. Then because of this urbanization, industrialization starts taking place, because everybody will start, the labor will be available, so industries start growing up, startups start growing up. The government policies also will form actually a major critical role in this. Then to address the existing increasing population, especially in the urban areas, infrastructure development takes place. That is the road, the transportation, etc., energy, the power stations, feeding the power to the cities, etc., etc. All those kinds, then the connectivity to the various surrounding areas. All these things come under infrastructure development. And the more more urbanization, more will be the industrialization, higher will be the industrialization, higher will be the environmental impact. And once the environmental impact, higher will be the greenhouse gas emissions. And higher will be the greenhouse gas emissions, thicker will be the blanket. So there will be lesser heat that gets escaped into the further atmosphere, causing the global warming and causing the man-made disasters. Once the man-made disasters come into the pictures, then the migration of what we have actually seen from urbanization to rurals, that is going to happen. Now, there is one interesting terminology called environmental refugees. Okay. Now, the population which comes from rural to urban areas, in search of jobs, in search of work, in search of better living style, in search of education, etc., etc. No, they come here with a purpose. Now, when the same migration, same population goes back, now because of, let us say, heavy rains, now the areas are flooded. Now, let us say all the workers who have migrated to Mumbai because of the heavy rains, because of the floods, etc., etc., they would like to go back to some areas which is safer. Nothing related to they don't go in search of better living conditions, etc., etc. They go only in search of safe place. So they may go to a little higher place, etc., etc., and then they get settled there. The first priority there is their safety. And then once they settle there, thinking that it is a safe position, and then all the other things start. So these people who go in search of safe places are called actually their environmental refugees. Now, what is the next impact? What is the next terminology we try to understand? We understand what exactly are our greenhouse gases. Now, greenhouse gases is actually a compound in the atmosphere that is capable of absorbing infrared radiation, thereby trapping and holding the heat in the atmosphere. That's what we actually explained just now and then discussed. Now, global warming is the increase of Earth's average surface temperature due to the effect of greenhouse gases. Now, these greenhouse gases which form the blanket, they actually do not allow the heat to escape. So the heat gets accumulated there and then causing the warming up of the globe, warming up of the Earth's surface, etc., etc. So the average temperature, the average Earth's surface temperature is, where is it measured? It is not measured at every point. It is actually measured at a particular point on one of the surface of the Earth ocean. I mean, is the Earth's average surface temperature. That is because 75% of the Earth is covered with water. So just 25% is Earth. So we need to take the average of that, and then the average Earth's temperature is increasing considerably. Now, this is what, when we talk about greenhouse gas effect, there are quite a few greenhouse gases. It is just not only when we, for example, when I say carbon footprint, which is very commonly used, carbon footprint is not the emission of carbon only, but it is the majority of it is actually the emission of the carbon dioxide, the gaseous material or the entities which come into the picture. Along with carbon dioxide, there is methane, all oxides of nitrogen, fluorocarbons, and then sulfur phosphates, etc., etc. Now, all these things actually are, other than carbon dioxide, are actually, for example, what you see on the screen, which is the methane, for example. Methane is very, very much deadlier than the carbon dioxide to the atmosphere. But it stays there in the atmosphere for a very short duration. That's why it's all these other greenhouse gases are converted into equivalent gas, carbon dioxide. And we say that carbon dioxide is the primary greenhouse gas because it stays very, very long period, almost about 100 to 150 years in the atmosphere for complete dissolving of the carbon dioxide, which means to say that, please remember, carbon dioxide, which is emitted about 100 years back, even if you stop emitting carbon dioxide today completely, let us say today we have zero carbon dioxide emission, is still 100 years accumulation is already there in the atmosphere, which will take next 60 to 100 years for completely get dissolved. So even if we, that is how the sustainable development, not adding or not increasing the global warming, becomes absolutely important. Now, the next important terminology is carbon dioxide concentration in the atmosphere. Now, this is measured using what is called as Keeling curve, and then the Keeling instrument, which is actually there. Now, the measuring of this is found by a scientist called Charles Keeling, mounted a set of monitors measuring carbon dioxide concentration in the atmosphere on mountain top of Hawaii, and in 1958, and then we are still using it. Now, in 1958, what you can see, the carbon dioxide concentration was about 320 ppm, parts per million. Now, in 2000, the latest 2020, the carbon dioxide concentration in the atmosphere is 417.16 ppm. Now, this actually, every day, this is available from the carbon dioxide data. And I had taken this about 4 days back. So 4 days back, the carbon dioxide concentration is about 417.16. If we reach about 450, it is extremely difficult for the human species to survive. So next, what is important is what is called as global warming potential. As I said earlier, the greenhouse gases, there are quite a few other than carbon dioxide. There are quite a few other gases, methane, nitrogen peroxide, fluorocarbons, and then sulfur, etc., etc. All these things are actually converted equivalent to carbon dioxide. And then that's why when we say carbon dioxide or greenhouse gases expressed in terms of carbon dioxide, all other greenhouse gases are also involved in it, converted equivalent to carbon dioxide. So this is actually called the global warming potential. Now, the next important thing what we need to know is the global warming itself. What exactly is the global warming? I would like to briefly recall your attention. In 2015, there was a summit called COP21 in Paris. COP21 is considered as one of the very important summits for the sustainability point of view, from the environmental point of view, wherein about 195 countries came together and then they signed. They understood that it is impossible for us to keep going this way. We need to curb at least by 2100, we should restrict, we should see that the global temperature does not rise beyond 2 degrees centigrade more than what is existing, the average temperature existing now. So, but if you see the green line, by 2100, we take all the precautions right now. If you keep taking the precautions right from now, by 2100, if we maintain, then we will be able to survive till 2100. But at the rate at which we are going, if we take the continuous current path, it will touch about something like 5 degrees centigrade increase in temperature, which actually is extremely difficult. By 4 degrees centigrade rise in the average global temperature, please remember that 50% decline in crop yield is projected. Melting of glaciers, loss of moisture from soil, changes in the rain pattern, heat waves, floods, droughts, cyclone, etc., will be continuously increasing. There are quite a few cities like which are the coastal cities of the world, including New York, Tokyo, Shanghai, Hong Kong. All these cities have the very fear of existence itself. If it raises by 4 degrees. Now, what we are talking about is increasing 5 degrees. That's why global warming, containing global warming, controlling global warming becomes absolutely important phenomena. Now, I also talked about polar amplification, which the melting of the ice and then the exposing, etc., etc. Now, there is another important phenomena. There is a lot of wood which gets actually hidden when the ice formation takes place, etc., etc. When the ice melts, all this wood which actually gets exposed to the heat when this iron melts, and it is all the rotten wood. And then because of the heat, when it catches fire, and then again, which increases and makes the glaciers to melt further. And not only that, it also enhances the greenhouse gas emission in the emission of the carbon dioxide in the atmosphere, which further adds. So this is actually a very complicated cycle, and this phenomena is actually called the polar amplification, and which results in the so many things. So in a nutshell, what we can actually understand is built environment from engineers' perspective is responsible for greenhouse gas emissions, and which also then directly proportional to the warming of the earth. Then indiscriminate use of natural resource materials in construction, resulting resource depletion, because we need more construction, etc., etc. We will start drawing natural resources, natural materials for the purpose of construction, for the purpose of infrastructure development, etc. And then this will considerably reduce the resources and cause resource depletion. The entire construction industry, construction process is extremely energy intensive, resulting carbon spike phenomena. I will come back to what exactly is carbon spike phenomena. Another important thing this built environment causes, what actually is, on the left hand side, the hourglass tell you that we have very little time now for the fossil fuel depletion. We are using it extremely unscrupulously, and then we are causing a lot of fossil fuel depletion, mainly the coal part of it, etc., etc., which has taken millions and millions of years by the nature for the formation. And other important thing is, it is not the human species alone that live in the on planet Earth. The entire ecosystem, The entire biosphere, the entire ecosystem comprises of several species. They say that it is around 84 lakh species, including human species, exist on the earth. And then by development of infrastructure, by building roads, etc., we actually cause what is called as habitat fragmentation, which you people would have seen considerably, elephants crossing the roads, cheetahs on the road, etc., etc. When we start occupying their space, where they take the roads through the forest area, the animal species get confused. They suddenly find something new in the regular pathway, then they confuse. So there are many countries. For example, in the right below sketch, what you see is this is actually to avoid habitat fragmentation. The road is kept as it is. The bridge is made. This is an underpass done for the vehicles to pass. But for the animal species, the pathway is left as it is. So these are the kinds of things which we keep saying. Now, I also talked about, there are a lot of other important adverse impacts which we are seeing on the screen. We have eutrophication, we have the global warming, fossil fuel, this thing, and then we talked about ocean acidification or rising temperature. All these things actually are adverse impacts of. Now, what we have in terms of engineering, what we actually have is what is called the planetary boundaries. Now, the entire environment is actually assessed and looked at it from almost 10 to 11 indicators. These are actually called the environmental indicators or eco-indicators. Now, these are actually the circle, what you see is one of the most active representations, graphical representations of the planetary boundaries. You have climate change, ocean acidification, all these things what we talked about. The one what you see, the yellow lines, for example, biodiversity loss, these are actually called the tipping points. The last red circle, what you call is the tipping point. Now, the red one is in the danger zone. The moment we see the inner red circle, that is this part of it, when you start seeing this red zone, this is where the tipping point comes, and then this is where we start tipping. For example, biodiversity loss in this area, in this segment, what we are seeing now is it is completely, we have overshot in the sense that we have already starting losing a lot of species because of the global warming, because of the heat in the atmosphere. Now, the other one is nitrogen cycle has considerably affected. The other one is because of the global warming, the climate has already changed. We have already reached the maximum tipping point, and beyond that, which almost is extremely difficult. But dear friends, we have no other go, isn't it? So that is why the first term on your title of the seminar comes, that the adopt. We have no other go. We need to adopt. We need to adopt these changes, but simultaneously, we can't remain complacent to what is exactly happening. So on the right side, what you see are the various effects of the global warming, which we already discussed. Now, we come to the next important terminology, what is called as the embodied energy. Now, every embodied energy is the total non-renewable energy that goes into the manufacture of a material and plays a large role in the choice of building materials. See, for example, let me take an example of produce the ceramic tile. And if you want to calculate what exactly is the embodied energy of the ceramic tile, now what is that which you need? Okay, now you need to take the entire life cycle of a ceramic tile. Now, entire life cycle of a ceramic tile, what is the starting point? Starting point is the extraction of the raw materials required for making the tile. And for extracting the material, you need equipment to extract the raw material at the site. So the energy consumed or the fuel consumed by the equipment is the energy consumed. Then the second one is the raw materials, what you extract from the source has to be transported to the factory. The energy spent or consumed in the transportation that is required. And when it comes to the factory, there is a huge amount of process which goes on in converting and then in heating the ceramic, addition of admixture, other components, other compounds, etc., etc., and then burning it to the tune of about 1400 degrees centigrade or something like that. And all this cause not only the greenhouse gas emissions during all these processes, because we start consuming energy, etc., etc., and then during the manufacturing process, and then packing it, and then delivering it to the site so that the site people can use it. And then once it is used, till it is in the operation period, do you make use of any energy for cleaning the tiles, for maintaining the tiles, etc., etc.? And then what is the till the demolition of the flooring or of the tile ceramic building. Now the embodied energy is the total energy consumed by the tile till it gets manufactured, and before it reaches the building. Now this embodied energy has got two types of energies. One is the initial energy, and then the other one is the recurring energy. Now, initial energy is again divided into direct energy. Direct energy is that energy which is used to transport building products, etc. Indirect energy is used in procuring the material, the process what we. Now, recurring energy is the energy consumed in the maintenance, etc. So, in essence, what we through the embodied energy which is required for the entire life cycle of it, tile, as the example what we took, is divided into some other different tiles. Next, actually, let us look at what is important is the embodied carbon. We have similarly embodied energy, and then embodied carbon also is there. What exactly is embodied carbon? During the process of entire manufacturing a product, now let us say we took the tile itself as an example. So when we manufactured the tile or the ceramic tile, and that is all these which are embedded in the manufacturing of the tile is the embodied carbon. Embodied carbon is the carbon footprint of a material. When I say carbon footprint, please remember that it is the emission of all the carbon greenhouse gases, including all other 5 or 6 gases primarily, and which are actually converted equivalent to carbon dioxide, and that is called as carbon footprint of the material. It considers how many greenhouse gases released, etc., etc., and it embodied energy is expressed in terms of joules per square meter or per unit or per kg or per volume, etc., etc. And then embodied carbon is expressed in terms of kg carbon dioxide equivalent. This is very, very important, the small e, which is equivalent. When we write equivalent, all other 5 or 6 greenhouse gases are all converted equivalent to carbon dioxide per kg. Embodied carbon can be measured from cradle to gate. Okay. Now there is very other important principle, what is actually called cradle to cradle, cradle to gate. I think I'll come to it during some of the next slides. Now, as engineers, most of us consider that what exactly is understanding these embodied many terminologies so far. Now let us come to understanding what exactly is sustainable construction. Now, sustainable construction has not been actually satisfactorily defined so far. Sustainable construction should be a part of sustainable development. It should follow the sustainability principles. All this at a macro level is fine. But what at micro level, what exactly is the sustainable construction? There are several definitions which I would not like to go on, which are available to you on your screen. You can refer it to it later. But what is important is the one which I have underlined. That is most apt definition which I felt. The sustainable construction is the creation and response built environment based on the resource efficient and ecological principles. All these principles, what we talked about, reduce, reuse, recycle, and understanding the various terminologies which help reducing the consumption of natural resources, etc., etc., should get involved in the sustainable construction process, so that we do not cause much deterioration to the ecological surroundings and to the environment continuously go on. Now let us look at what exactly is the sustainable construction involves. Actually, sustainable construction involves very wide scope of activities, and primarily it can be said that it starts with actually the designing part of it. How do we use the space part of it? How do you optimize the space part of it? Now let us say we have full area, we have an extension, let us call it as Jayanagar, and in Jayanagar I have a 60/40 site. In 60/40 site, how do I actually optimize all my requirements? And so that is the space, that is the planning stage where it comes into it. And once the planning stage is completely done, and then the structural design part of it. So these are actually the pre-construction phase of the material, we can say. The space and structural design, and then the convention and alternative materials. We also should list what exactly are the materials which we are going to use. Are they going to be local materials? Should we get it from outside because of their non-availability? What is my requirement? And now we need to assess the sustainability part of it, how sustainable the building, what I'm going to build is going to be. Then the construction technology, what kind of technology am I going to use? Am I going to construct using conventional method? Am I going to use a precast method? Am I going to use monolithic method? What type of technology do I use? So that comes into big picture. And next important aspect is the building automation. As the technology advances, we need to use a lot of automation possible. May not happen in individual residential buildings, but it does happen from safety point of view, from several confidentiality point of view. It becomes very necessity in industries, high security places, etc. Then the construction mechanization and artificial intelligence also should become a part of the entire sustainable construction. And whether I like it or not, whether you like it or not, but this is how the whole industry is traveling. The evolution of the construction industry is taking place. We have new generation materials, we have new software, the new technologies of analysis, we have the new the automations for optimizing the energy consumption, etc., etc. And because of the labor problem, because of the several the productivity improved, enhanced productivity, we have lot of mechanization, lot of construction equipment, advanced equipment come into the picture. So this is where the construction mechanization comes into place. So next slide, what I'm going to talk to you is about, just bring back your attention to the life cycle cost, to the life cycle what we talked about, and I spoke about a phenomena called carbon spike. Now on your screen, what you say is these are the 4 phases of the construction of a building, let us say. Now a pre-construction phase, construction phase, then operation and then maintenance phase, which is the phase 3, and then the demolition phase. See, operating and maintenance phase, which constitutes about 75 to 80% of it, and the remaining 3 phases together will constitute about 20 to 25%. The majority of it happens in the construction phase. Why? You can imagine which is the most important point during the construction. What is that one particular product or few products which cause very high impact on the environment? is actually the cement content in the concrete and the reinforcement, made out of virgin ore. Now that is the virgin steel, what we call. It is not, when a steel is neither recycled nor reused, it is actually called the virgin cycle. Now these are the 2-3 items, and then there are a lot of other parameters which are there, which contribute less. But all these things actually get used mainly in the construction phase itself. So that is why in the construction phase, which may, let us say if the life cycle of a building is about 60 years or so, then the other thing which the construction phase may be actually about 20-25, 2 to 3 years, the carbon spike or the carbon hike is extremely important. Okay. Now there is another important, and that is why the construction phase becomes extremely important. Now there is what is called urban heat island. I already talked about it. When the infrastructure improves, when the infrastructure grows, we cover the surfaces with concrete, the more heat gets reflected back, and the more amount of construction, the more amount of heat gets. So that is the urban island effect, and then actually it affects the microclimate, etc., etc. Now then, these are the 17 goals. Now let us come to the sustainability goals. Now I talked to you about the COP21 in 2015, about 195 nations came together, and then whether irrespective of developing country or underdeveloped country, we have all the countries actually divided the entire global challenges into 17 challenges, and those 17 challenges are actually called the 17 Sustainable Development Goals. The idea of doing this is by 2030, that is 2030, I don't know, 2030 is considered as extremely important from the global agenda point of view. All the countries on planet Earth have committed themselves to see that by 2030, carbon emission becomes zero. So, which actually is only 10 years ahead, and which we actually have long way to go. Our efforts are not at all sufficient. It is not only Indians. India, in fact, is much far better, but the other countries, etc. So this is where the confusion comes. Should we not look at the sustainability only? No, the actual smartness of engineers come into the picture, where when we strike a balance between the sustainability development and industrial development. Now let us also, these are the 17 goals which you can actually make study. They're all called 17 Sustainable Development Goals. Now for civil engineers and construction engineer industry professionals, there are quite a few goals which are extremely important. One, what you see, these are the goals, these are the 7 goals which are extremely important to civil engineers. Goal number 4, goal number 6, etc., etc. You can go through in detail, but we here as engineers, as designers, as architects, as town planners, and the manufacturers, all these people actually are responsible for directly responsible for about 6 sustainability development goals. Now comes what is our role as engineers, as construction industry professionals. When I say engineers, it means all those professionals who are involved in construction industry. So how do we do that? How do we mitigate, first of all, the strategies? How do you reduce all these things? The first one is the adaptation, which I said. We need to adapt to the changes, and which we are automatically doing. If the global temperature increases, what we do, our whole biomechanism, our whole system automatically gets increased. So we probably provide, what we are now doing is, if the heat increases, we put one more AC and then get ourselves cool, which is not the right way. But this is what we are adopting, the manner in which it is not required. We are adopting ourselves to the changing conditions. Now, the second parallel thing is, so we need to adopt in a way that it doesn't further affect the natural environment. That is the first step. Then the second step is the mitigation. That means human efforts to reduce global warming. How do we restrict the temperature, and what mechanisms, what steps do we take? And then the third step in the mitigation is the decarbonization, is the forward. Now, what exactly are these things? We will slide very quickly, look at it in the next 2-3 slides. Now, adaptation to climate is already changing. Now, this phenomena is extremely important. If our life cycle of a building is about, design life of a building is about, let us say 60 years, 70 years, now there is already what is called in as a lock-in period. That is what I said about carbon dioxide, which is already emitted about 75 to 100 years back, is still in the atmosphere. It is not yet dissolved. So even the slightest accumulation or addition to that atmosphere, that greenhouse locked in GHG, which has formed in the blanket, it further increases. So there is what is called a lock-in period. Now, if as a designer, if I do not, for a building design today, and if my building design life is about 60 years, let us say, or 70 years, if I don't consider for this building the environmental impact, we are not truly doing any justice at all. And this is where we have miserably failed. So we need to look at the designing paradigm shift has to be brought into the designing aspect itself. So now climate change is global agenda. As I said, 2030 is very important, and that is the adaptation part of it. Now, what is the sustainable adaptation, the urban resilience, etc., which we have already discussed about these things. So I would like to quickly go skip this slide and come to the decarbonization as engineers. Now, how do we decarbonize? What exactly is decarbonization during the construction methodology? How do we reduce the emission of carbon dioxide? We need to adopt measures to reduce fossil fuels burning. That means clean energy options have to be adopted. Increase the carbon sinks. What exactly is the carbon sink? That is the afforestation has to be done. That means carbon absorption has to be done. At the same time, conversion of carbon absorbed into the oxygen has to be converted, which means to say that we need more forests, we need more greenery. So that is actually a forest area, a green cover is actually called the carbon sink in general way we can take it as. And exploding population has to be completed, controlled. Energy efficiency, efficient energy systems we need to have, adopt clean energy, shift from fossil fuel to renewable energy, which we talked about. Solar, it can be solar, it can be wind energy, it can be tidal energy, it can be anything else other than the fossil fuel energy. And then re-engineer high energy materials. That means you start using those materials which have got lesser embodied energy, those materials which have got lesser embodied carbon. All these energy economy has to be brought. Now, introducing smart grids, etc. Increase the recyclability, reuse, and reduce the waste emission, reduce the waste generation. And in a nutshell, decarbonization comprises of 3 major steps: energy efficiency, low carbon power, and then fuel switching. So these are actually the most important things come in our way when we start talking about the decarbonization method. Now, what exactly, let us look at the emerging trends in the construction technology. Now we have certain, it's projected that urbanization, this pandemic, the 3-4 months or 5-6 months what we are facing is a very temporary phenomena. People are going to again come back to the cities for etc. etc. Urbanization is going to be there. It is inevitable. Now, when the urbanization is going to be there, there will be a pressure on the land mass. Sites will not be available. Land for the people who come into the urban areas are not available. So we start building different technologies, construction technologies, we start using it. These are the few very popular technologies which are going to be very effective, etc. One is actually the pre-engineered buildings, which will be very popular. Then the precast construction, which will come in their way. Precast construction reduces lot of improves lot of quality, reduces waste generation because it is done at a ground level. Quality is maintained, material wastage is minimized, and then construction mechanization takes place. So it harms the environmental also less. Next, we have the precast honeycomb construction, which is also a composite kind of a construction. Next, we have what is called the biomimicry. That is, you mimic the nature and then build your, reduce your environmental effect. The tilt-up construction technology, where the construction is done in panels just next to the site, cast it like a precast unit, and then tilt it up like what you are seeing actually in the site. For high-rise buildings, we have slip form technologies and then the jump form technologies. There are, dear friends, the formwork and the advancement in the formwork technology is altogether a different subject, which we have completely, we never get exposed in our during the course, engineering course, etc., etc. This is extremely important for us to understand what formwork is there. That itself is a course by itself, and then we require at least about 4 to 5 hours to cover what exactly are the different formwork. But this is what the slip forming, the tall structures need these kinds of technologies, different technologies. The monolithic wall construction with aluminum, the wall and then the roof. Each floor is constructed together, and that is the monolithic wall forms, and which are actually aluminium. The advantages and disadvantages, we will try to see if there are many. These are the flying form tech. From these things, we have what is called the construction mechanization. There are a lot of, because of the labor, non-availability of the labor, non-availability of the skilled labor, we have a lot of equipment from small to big are coming in the way of construction. So this is actually called the construction mechanization. We need to take use of this also to increase the productivity, to improve the quality, and then to minimize the use of natural resources. For example, the reinforcement, which is factory fabricated, everything is the AutoCAD drawing is gets integrated with the bar bending schedule software, and then the fabrication is done, the bending, the cutting, everything is done. The particular reinforcement is designated in bundles, as you rightly see it. For example, beam number so and so have got a designation. So once this is done in the factory, then it becomes a part of the construction mechanization. It is only installation. So there is a lot of advantages which we see in the construction industry. Now, coming back to the new generation materials, we cannot completely retain only the old generation materials, but new generation materials. For example, we have bendable concrete, self-healing concrete, translucent concrete, electrified wood. We have bioengineered bricks, sensitiles, so several of them. Then we have actually 3D graphene. All these things which are coming, which you see on the boards, huge number of new generation materials are coming. They actually impart, they're more efficient, highly advanced technological, and then you optimize the energy, help us to improve a lot of parameters in the development part of it. So this happens to the construction material. There is also a rammed earth technology, which is not very popular in India, but earlier every building used to follow this. And then I am also involved right now in about 3 to 4 projects near Pondicherry using rammed earth construction. So this also is one of the very popular, and quite a few architects, we should all appreciate them. They are using these technologies. Now they are trying to bring back these eco-friendly structures. And then these are the materials which we talked about it. You can see, get these things from the Google, the materials and even the technologies, which are actually the mortarless technologies which have come into the picture. There is no cement, there is no mortar, the self-interlocking materials come into the picture. Now, these are the autoclaved bricks. Now, we come, last few slides, we come little technical into the this thing. How do we analyze this, and then how do we actually understand the sustainability part of it? Now, as we know that there is already construction materials are available to us, then there is already embedded energies, that is embodied carbon, and then greenhouse gases or the embodied carbon in the materials which is already embedded. And we also have actually the outside. In the outside, there is a phenomena. There are a lot of greenhouse gases which is the locked in, which is so essentially a sustainable construction, or when we talk about sustainable development, it is actually understanding the interaction of the construction materials, embodied energy, the embedded energies, greenhouse gases, and then the outside. It is all the synchronized or the synergy effect of this material. All these parameters have to be understood to understand actually, or to measure, to quantify, to assess the sustainability of a particular building. We all know that this is the activity percentage of generally this thing. We have, for example, superstructure, which costs about 25% of the total cost of the building, etc. These are the actually economic percentage-wise taken. And for example, 20% is the superstructure which takes part of it. All other things are joinery takes about 15%, etc. This is for the conventional building. Now, when we start assessing from the sustainability point of view, let us quickly go through these slides. I have taken a 18-floor building, which is a RCC framed structure, because it is the urban areas which you get more and more impactful. And so the total area is about 2.5 lakh square feet, or 25,000 square meters. We use the solid concrete blocks, etc., etc. Now let us look at the sustainability assessment. Kanmani, can I take another 5-10 minutes?
Yeah, sure, sir. Sure, sir.
Yeah.
Continue.
Yeah, thanks. So let us understand this sustainability assessment using three very, keeping the life cycle analysis in the backdrop. We will try to assess the building from embodied energy perspective, from embodied carbon perspective, and then this SDI perspective. What is SDI? SDI is Sustainability Development Index. The United Nations Environmental Program and then the UNDP, UNEP both ask for what is called as developing locally applicable sustainability development index, because the climatic conditions of Bangalore is not same as climatic condition of Jaipur. Okay, climatic condition of USA is not same as climatic condition of India. So there is no point in using those materials. We have a fancy, for example, glazing does not actually suit the subcontinent Indian climatic conditions. Except in cold climatic conditions, it may be suitable, but not in the other areas. So this is where the UNDP, United Nations Environmental Program, and United Nations Development Program actually ask for evolving locally applicable sustainability development indices. What is sustainability development indices? We will see later. Now, from the embodied energy, what we do when we start talking about the embodied energy perspective, we talk only the assessment and embodied energy is the life cycle analysis through life cycle. The assessment is based on the energy consumption through building's entire life cycle. That is cradle to grave. Okay. Now this is based on the real-time data or the bill of quantities, and then depends on the various inventories. So essentially, embodied energy bases its assessment based on the energy consumption. Similarly, embodied carbon assessment is based on the greenhouse gases emitted through the building's entire life cycle, that is cradle to grave. Now the SDI, that is the Sustainability Development Indices, actually is an algorithm which is based on the several eco indicators, including embodied energy, embodied carbon, climatic conditions, then there is a transportation coefficient. All these things, so several eco indicators are included. Now, let us look at it slightly more detail. What you see is the sustainability engineers, material properties become extremely important. See, I cannot, for me, density as a structural engineer, as a civil engineer, for a high-rise building, the strength of the material is absolutely important. Modulus of elasticity of the material is important. Its density important. Several other material properties are very, very essential for me also to consider my design aspect. Now, we have already seen what are the embodied and embedded energies, embodied energy, embodied carbon, etc., which is in the materials. Then water is another important, and the coefficients of embodied energy and embodied carbon, transportation energy, design period, operational energy, cost stimulators, or cost of construction, cost of labor, cost of all these parameters actually vary from place to place, and that is why all these parameters have to be integrated, and then a mathematical formula or mathematical assessment has to be done, and that actually is called Sustainability Development Index. I had an opportunity to submit to the nation this ASP SDI, which is called Assessing Sustainability Parameters through Sustainability Development Index. So this Sustainability Development Index actually is applicable to all climatic conditions at the conceptual stage. That means before the construction of the building takes place, everything can happen. So this Sustainability Development Indices, which is developed, which is applicable for all the climatic conditions, is based on about 28 ecological and engineering parameters expressed in terms of percentage as compared to a benchmark project. So these are the three important assessments. One is through embodied energy, the other one is embodied carbon, the other one is through Sustainability Development Index. Now, we can calculate for the case study what we have taken, we can actually put all the activities in these 10 to 11 parameters from the bill of quantities, from the planning at the planning stage itself, and then the total embodied energy per square meter can be calculated. Okay, now that embodied energy comes to, let us say, 5,18573 megajoules per square meter. Now this is the embodied energy. Now if this is how the P chart with respect to the these parameters, these 10 or 11 parameters, when we put them into primary chart, and the total embodied energy is 5.185 gigajoules per square meter, or 5185 megajoules per square meter, out of which you can see from embodied energy perspective, concrete causes about 53% of impact per square meter in that particular building. Steel causes about 22%. Other bigger important, which is the formwork, causes the 11% of the impact, because this is a conventional formwork which they have used. So all other percentages also can be assessed and then put through, can be expressed like this. Now, how does it, in terms of quantification, in terms of amount, now let us say embodied energy per square meter, it comes to about 5.15 gigajoules per square meter, and total embodied energy for the entire building comes to about 13 crore megajoules. And if you convert those megajoules into 1 unit of electricity, it comes to about 3.64 crore units. Okay, now 3.64 crore units at the rate of 8 rupees per unit, if you take it as a commercial rate, it comes to about 29 crores. Do you understand that 29 crores is the embodied energy component in this particular building? Now, similarly, if you start doing applying sustainability measures, etc., the benchmark value is 3,500 as against 5,186. So if you start reducing and applying various mitigation strategies, what we discussed, and start going towards this 3500. Let us assume that 5186, I bring it down to 3500 megajoules per square meter, then my saving would be about 9 crores in a project of that size. Okay, this is just to give you an idea from the finance perspective. Similarly, embodied carbon can be actually calculated for the entire project per square meter. Here it comes to about 483.75 kg CO2e per kg is the total embodied carbon component for that building per square meter. And similarly, when we express it, and even from the embodied carbon perspective, the same parameters, for example, concrete, steel, formwork, give indication. Now, when we convert that into, again, the finance equivalent, about the total component comes to about 10 crores. So this is just to give an indication how much important the embodied energy, by reducing embodied energy and by reducing embodied carbon, by saving the materials, by using the recycled materials, etc., etc. All these things can be achieved. Now, similarly, from the sustainability development indices, it involves lot of calculations, lot of tables, and for intricate works. But ultimately, let me just come back to you. This, for example, for this particular building, as I said, it is the synergy interaction, and the total energy interaction comes to about 30,291. So this is just a number. It is the unitless number, which ultimately get expressed in terms of percentage. Now, through the same, as we do the P chart expression, we can identify the steel component and the formwork component and the concrete component. Beautifully is concrete component forms much less impact. That is for the simple reason that we have contained lot of other parameters. Concrete is the only material which survives, which is durable for a very long time, which will be there for a long time. After it is cast, it requires very little maintenance. All those things come into the picture, and then that is why the component becomes extremely less. Now, similarly, these things, since most of you are students, we can apply it for every system. See, there is no individual item which can be used. Cement cannot be used as an individual item in construction. It always has to be used in terms of metric, as a part of matrix. So formwork, for example, this was done by one of the M.Tech students under my guidance. So conventional formwork, plywood formwork, and aluminium formwork, these are the different typologies. And then based on embodied energy assessment, embodied carbon assessment, and then sustainability development indices assessment, all these assessments, the tabular of this thing, you can see conventional formwork has got very high impact in terms of sustainability, because there is no repetition or reuse. Maximum usage is about 4 to 5 times. Then it becomes a waste. But plywood, if you use, there is a moderate impact because number of repetitions are more, and then the supporting system is much different from the conventional system. When you use aluminium formwork, the aluminium formwork, from embodied energy point of view, from embodied carbon point of view, it has got high embodied energy. But when you use it as a system, it gives least impact because 85 to 95% of the aluminium can be recycled. So there is one recyclability comes into picture. The number of repetitions are about 200 to 250. So reuse comes into the picture. And then because of using this, we get extremely high good finish. And then where the plastering activity is completely reduced, so the reduce. So all the three principles of recyclability, reduce, and then reuse come into the picture and contribute to aluminium formwork. This is how, as an engineer, we can use our discretion and then come to the understanding of the entire aspect of it. So similarly, you can represent for the walls, calculate for the walls, and then window materials, and then for particular project, we can do all these things. But the present assessment also have got a lot of limitations. The data is not available. That's why locally available data is to be used to the extent possible. And then a smaller footprint we need to achieve. We a lot of parameters. In this way, we can assess the sustainability buildings and then go ahead with this. I think with this, I have come to an end. Lot more to discuss, but due to paucity of time, I will say thank you very much for patient hearing. I only hope that, because from my side, I am not able to see anything. It's only talking. But I hope all the participants could hear about it. And Kanmani, over to you. My presentation is over.
Thank you, sir.
Again for all the participants.
Thank you, sir. Thank you for that informative session on understanding the importance of sustainability and the effect of urbanization, global warming, and other human deeds on environment. Now, let's go, sir. Let's go, and I'll just pass on a few questions to you, asked by the participants.
Okay.
The question number 1 is from Abhilash. The question is, how can we manage the economic aspect, which is in 3 pillars of sustainability, in terms of strong sustainability in construction sector?
Yeah, that is why I gave you the 3 slides from the economic point of view itself. Suppose embodied energy point of view, I gave you the financial output, taking in the case study. Now, how do we reduce the economic point of view? How do you, by bringing down the material point of view, increasing, using those locally available materials, using the locally available skill, and then reducing the transportation energy, all those parameters have to be considered into the design aspect of it. And then we need to strike a balance between modern advanced technology that are available, locally available materials, locally available resources, let me put it that way. It could be labor, manual resource, or the material resource, and the financial resource. All these things, at every stage, we need to do the life cycle analysis of a particular building, and that is going to be a tough time. That is why lot of software, lot of things which are available, systems are available now. For example, there is a software called Edge, where you can actually feed the input all the building materials, data and parameters, and finally you will get a fair amount of where do you stand from sustainability point of view. And for example, the one which I talked about, ASP SDI, is another sustainability development indices, locally based, climatic condition based. This probably needs another session which talks about how do we actually go and assess every building and then approach it from economic point of view. Did I answer your question, Abhilash?
Yeah. Yes, sir. So the next question is from Ajay Shinde. The question is how to control this year by year increasing carbon dioxide in atmosphere, and what kind of action human have to do against it for controlling or prevention?
Yeah, it's a good question. But see, every activity, for example, let us take only construction point of view. We need to see, we have all those values, lot of data which is available, which has got high energy. I gave you the example of aluminium formwork, for example. As an engineer, I would like to use that kind of a formwork which has got least effect on the environment from greenhouse gas emission point of view. See, for example, when in Bangalore, granite is available in plenty. Is there any sense in bringing costliest marble from Rajasthan and using it in Bangalore? For example, that should answer your question for simple material. Why can't we use the granite? It's such a beautiful material, and it is a local material. It is proved, it is plentifully available in a particular locality, because it suits the surrounding atmosphere. That is why it becomes a rural material. So that material is available to us easily. The transportation is less, and because of the transportation, the greenhouse gas emission becomes less. On the contrary, if you transport the marble from Rajasthan to Karnataka, what is the cost of the transportation? And it is not only the cost of transportation, we have to burn fuel for that. Yes. And when fuel energy is burned, it gives carbon dioxide emissions in the part of it. So in every activity, the construction mechanism, part of it. That's why especially in the construction phase, we need to take a lot of care, use a lot of, I gave you the steps for decarbonization methodologies. Please go through the presentation once again. What are the various steps for decarbonization? I have already given the various steps for decarbonization. How can we reduce the carbon dioxide emission and increase the carbon sinks? Please, it's just ridiculous to keep on cutting the trees and then reducing the carbon sink and increasing the carbon dioxide. We are actually doing everything against what we are not going to do.
Okay, sir. Sir, another question from Sindhuja Uppala. The question is, what is tilt-up construction? And is tilt-up construction implemented anywhere across India?
There are many places tilt-up construction. See, tilt-up construction is there. It's almost similar to precast construction. Precast construction is done in the yard, and then you transport, for example, the metro girders, what you see. Now, these girders are cast in the casting yard, and then they are transported to the site. Whereas tilt-up construction, the panels, let us say if you have a ground floor, each one full panel is cast adjacent in the site itself. So for that, your site should be big. It is not applicable for a 30-40 site or something like that. Your site is big, and then where the repetitions become much bigger. So you actually place the wall panel, for example, as you saw it in the sketch, and then using the crane, tilt it up. So the foundation is made earlier, and then tilting up will require a lot of gadgets, a lot of precast, pre-engineered anchors to hold the tilt-up construction, etc., etc. There will be male and female joints at the foundation level. That I didn't go, but as a technology, it is tilted. The wall panels are tilted and then connected to each other. Okay, it is being used, and then L&T has used this in quite a few projects.
Okay, sir. Another question from Pratap Kumar J. He wants to know about the details of eco bricks.
Yeah, eco bricks are, for example, fly ash bricks. All those bricks which are manufactured out of waste. There are bioengineered bricks are there using sand there, and then some microbials. They are now trying to evolve bricks using plenty of sand that is available. They are called bioengineered bricks. The fly ash bricks are eco bricks because fly ash is available as a waste materials. Slag is available. Then aerated concrete blocks, what we talk about, that is being done. For example, some of the concrete blocks which are manufactured by replacing some of the cementitious material, that is eco bricks. So anything that is those bricks which are for example, now soil cement blocks are there. With a very little amount of percentage, about 5% or 3 to 5%, or many people have used 8% also. So they're all compressed soil cement blocks, CSEBs are there, earth blocks are there. All these are actually eco bricks. And all of them are available in the market.
Sir, one more question from Preetham Kumar. Can algae farming be introduced in the sustainable construction method?
In the water treatment, yes. In treating of the water, it is possible. but not in the construction method. I didn't understand what exactly he means by that.
Okay, sir. So the question he typed is just, can algae farming be introduced in the sustainable construction methods?
Yeah, in the sense that there are methods which are, let us say, plants and herbs oriented, that is being tried in several places as far as the water treatment is concerned. I'm not fully acquainted with it. I'm not an expert on water treatment. So, but in construction, it's not done.
Okay, sir. I'll take one last question. There are a number of questions.
Okay.
We'll have the last question, sir. It's from Narendra Kumar.
Yeah.
Economic superpower USA is not signed authority for climate change and global warming. Then how to control carbon dioxide, sir?
It's indeed a good question. Actually, see, I referred to COP21 where 195 countries signed. It is that time Obama was there in the US as head of the state, and then he actually approved about $100 million every year to achieve, to improve the sustainability technology, etc., etc. When the next government came into the picture, when Trump came into the picture, he said he did not give much importance to the sustainability aspect of it. That's why he withdrew that this thing. So there is a lot of opposition even in the US itself for that particular action. But nevertheless, one country doesn't, if one country is not there, a lot of other countries, other 194 countries are doing that. But there is a lot of opposition, a lot of support. But even today, after all having said and done, even today in the US, there are a lot of people who are practicing sustainable these things, etc., etc. It is not the government job only. Whoever has asked me the question, it's the duty of each one of us to take forward and then make our own contribution, individual contribution. Then only it's possible. We can't just leave it to the government.
Yeah, thank you, sir. Thank you for answering with lots of patience, sir. Now I request Professor Anjan, sir, to deliver vote of thanks.
Good afternoon, one and all present. As we have come to the end of today's webinar on understanding sustainability, adopt, assess, and mitigate. It's my privilege to propose the vote of thanks on this occasion. On behalf of our department, I acknowledge and convey my heartfelt thanks to the resource person, today's speaker, Dr. AJIT SABNIS, Principal Consultant, ASP SDI Sustainability Assessment Consultancy Firm, Bengaluru, for sharing the knowledge and experience on roles and responsibility of all of us towards achieving 17 Sustainable Development Goals. Thank you so much, sir.
Thank you.
And I take this opportunity to express our sincere thanks to VVC management and our principal, Dr. B. Sadashivegoda, who always been the great support behind such events. Thank you very much, sir. It's a matter of immense pride for me to convey my gratitude to our HOD, Dr. S.K. Prasad, for his continuous support and motivation in conducting such events. Thank you, sir. I would also like to render my gratitude to the convener, Dr. H.S. Dayananda, and coordinator of this event, Dr. P.K. Umesa and Dr. P.S. Silpavanam. Thank you, sir. I would also like to render my thanks to moderator, Professor Arjun, for helping in broadcasting of this event, and I thank all my fellow colleagues, technical and non-technical staff who helped in conduction of this event. Thank you. I would like to thank all the participants for their kind cooperation and see you all tomorrow morning at 11 a.m. for the next webinar on urban noise pollution, sources, impacts, measurements, and control by Dr. Harish Puleria, Assistant Professor, IDP in Climate Studies, IIT Bombay, Mumbai. Thank you all. Over to you, madam.
Thank you. Thank you, Anjan sir, and thanks to Ajit sir also. Thanks again to all the participants for joining us today, and we look forward for all your presence for tomorrow's Day 5 webinar on urban noise pollution, sources, impacts and measurements and control by Dr. Harish Puleria, Assistant Professor in Climate Studies, IIT Bombay. Thank you all. Thank you.
Thank you so much.